Hey guys, this video is just to go along with the PowerPoint that I posted to the Google Classroom on current electricity. There's just a few points that I want to make sure everybody understands before we move forward and actually start drawing circuit diagrams. So current electricity is actually electricity that moves along a pathway. And this is different from static electricity, which is what we learned in class, because static electricity is electricity that builds up in one spot. Current electricity, though, is electricity that actually moves along a pathway. And current electricity is really the way that we power the majority of our lives. Your cell phones, computer, this tablet that I'm working on, everything that you turn on using a power source, that is using current electricity. So current electricity moves along a pathway, and that pathway is called a circuit. Okay, and every circuit has four basic components. It has a power source, it has wires, which are conductors, it has a device that you're trying to turn on, and it has a switch to control the on and off start stop option of the device. The switch is not mandatory, so a circuit will work without a switch. The only thing that will happen is the circuit will never actually turn off. So this unit, we are going to learn how to draw circuit diagrams. And circuit diagrams are just an illustration of what the circuit actually looks like. So every circuit needs to have a power source, and a power source is usually a battery, or it can be a wall outlet. And remember, in the PowerPoint, I gave you the symbols for all the components of the circuits that you are going to be responsible for drawing. Those symbols are universal, meaning everywhere around the world, everyone uses the exact same symbols. So keep referring back to that PowerPoint until you actually have those symbols memorized, okay? So every circuit requires a power source, and it requires a power source because that's where the electrons actually come out of. So I'm going to draw a one-cell battery here. And a one-cell battery has a symbol with a short line and a longer line. One end is the negative terminal and the other end is the positive terminal. This is actually what generates the electrons that are actually going to flow through the circuit or flow through the pathway. So it's extremely important that the power source is there, or else you have no electrons that are moving around. So what happens in current electricity is that electrons travel around a pathway. They leave one end of your power source and they travel all the way to the other end. So the electrons leave from the negative terminal and they're traveling all the way around until they get back to the power source at the positive terminal. So it's movement in one direction. So always from the negative back to the positive. And the electrons actually have to reach back to the positive end of the terminal if the circuit is complete and it's actually going to work. Okay, so that's the first thing that we have to know. We have to make sure that we know that every circuit has to have a power source, because that's where the electrons leave from. They leave from one end and they return to the other, okay, going in one continuous path. The next thing that we need are wires, and wires are important parts of circuits because wires are made up of conductors, and conductors actually conduct the electricity, so they allow the electrons to actually travel through them. So when I'm drawing my circuit, these lines that I'm drawing, that rectangle shape, that's actually made up of wires, and those wires are wrapped in insulators for safety reasons, but inside the wires are metal filaments, and that's where the electrons actually travel because metal is a good conductor, and conductors allow for electrons to travel through them really easily. The next thing that you need are actual devices. So for example, if I wanted to draw a light bulb, two light bulbs, let's say I wanted to turn on two light bulbs in my circuit. Those are my two light bulb symbols. Those light bulbs can only work if the electrons leave the negative terminal, they reach through, right? They get to both of them, and then they actually return all the way back to the positive end of the terminal. That way, the electrons are actually going to power the light bulbs to turn on, okay? And the last thing that we need that you can include is a switch, and a switch, all it does is it just lets you turn off the device. Okay, so your question asked you to draw a two-cell battery so let's do that first. They wanted a 2-cell battery, so I'll do 2 cells. One end's a negative and one end's a positive, with an open switch. So I'm going to put an open switch. Now, I always draw my switches right after my battery, so you can follow suit. Then it's asking you for a motor, an ammeter, a light bulb, okay? And then it wanted a resistor. So I'll continue here. I'll draw a resistor, put it in the circle, and then finish off my circuit. Okay, so you'll notice that a circuit diagram always takes on the form of a rectangle. This is an open circuit. It's an open circuit because there's a gap in your switch. So what ends up happening is, let me just show you here. This is a gap right here. This is a gap. So the electrons have the potential of escaping out this way, which means they won't reach the motor and the light bulb, which means the actual circuit won't work. If there is a break or a gap in your circuit, then that means the devices, the loads, won't actually function. If it was a closed switch, then it would. Hope this helps. The second question and the end of your PowerPoint asked you to draw a circuit with a closed switch, 1 cell, a clock, a light bulb, and a ground wire. So let's do that. Let's draw a 1-cell battery, negative end, positive end. We want a closed switch. So I always draw my closed switches, or my switches, right after my battery. So there's my closed switch, okay? A clock, so let me draw that next. A light bulb, okay, and then it's asking for a grounding wire. And a grounding wire is big, small, small. And there we go. Okay, so now let's make sure we have all the components of a circuit that we need. So I'm noticing here that I have my power source, okay? So my power source in this example is a 1-cell battery. I know that my electrons leave from the negative end and they travel all the way around until they reach back to the positive end. So I'm going to keep saying that to make sure everybody understands that. The next part is closed switch that they asked you for. Here's your closed switch. The closed switch means that there is no gap. There's no break in this circuit. So will the clock and the light bulb actually turn on? Yes, they will, okay? They'll turn on because the switch is closed, and that means the electrons actually have no way to escape, so they're actually going to return back to the positive end. And then you have your 2 loads, which you need. You have your wires. And everything looks complete here. The only thing I want to remind everybody of is neatness. When you are drawing at home, you are using a ruler for your wires because it is mandatory. I don't have a ruler on this program, so I'm not using one, okay? So hope this video helps. And tomorrow we're going to actually start talking about the difference between circuits. There's 2 different types, okay? So talk soon.